Hello everyone. After understanding speed, types of speed, velocity and types of velocity, now let's move on to the comparison between average speed and average velocity. The first point of difference is in the formulae. Look at the formula for average speed. It is the ratio of the total distance travelled to the time taken. On the other hand, the formula for average velocity is a ratio of the total displacement to the time taken. So you can see that the numerator for speed has distance, whereas the numerator for velocity has displacement. However, both depend on the time interval, as you can see from the formulae. The second point of difference is very simple. They say that average speed is a scalar, and it is so because distance and time are both scalars. Average velocity, on the other hand, is a vector, and this is because it depends on displacement and time, out of which displacement is a vector. And therefore, the second point of difference is basically saying that average speed is a scalar, whereas average velocity is a vector. The third point of difference deals with a very important case. It's the specific case when you're talking about an object which comes back to its initial position after motion. So let's take an example. Suppose you're sitting on a giant wheel. We know that after some time I'm going to come back to my original position, and I do so after one revolution. So what would be the average speed in this case? By definition, average speed depends upon distance, and we know that distance is nothing but the length of the path travelled. So take a look at the length of the path travelled when you are moving in one revolution. And of course, as you can see, the distance travelled is not zero, and therefore average speed would not be zero. On the other hand, if I try to think about what would be the average velocity in such a case, let's think about the average velocity. Average velocity depends on displacement, but in this case the displacement is zero. And why is that? Because by definition, displacement is the vector drawn from the initial position to the final position. But since the initial and final position are the same point, I can't draw a vector for displacement, and therefore average velocity is zero because the displacement is zero. So basically I am trying to say that if you come back to an initial position, the average speed may not be zero, but your average velocity is definitely zero. The next point of difference says that if you are in motion, there is no chance that your average speed will be zero. And this is because the average speed depends on distance. Distance by definition is the length of the path travelled. So if I am in motion, I am definitely covering some distance. So distance cannot be zero. And if distance cannot be zero, then average speed cannot be zero. On the other hand, even if I am in motion, my displacement can be zero, as we just saw in the example of the giant wheel. And therefore, just because the body is in motion, it doesn't guarantee that the average velocity will not be zero. It in fact can be zero in the case we have just seen, that is when the body comes back to its original position. We also note that since distance can never be negative, by definition, it is the length, and therefore distance can never be negative, average speed also can never be negative. On the other hand, displacement can be negative because it's a vector, and therefore average velocity can be negative. So in conclusion, this point is trying to say that average velocity can be zero, average velocity can be positive, and it can also be negative. To sum up, let's take a look at this example. If I have a ball and I throw it up in the air, from a point on the ground to some point in the air, then I can take a look at the distance travelled by this ball. Let's say that the height of this is 2 meters. So quickly let's write down what is the distance and displacement in this case. Straightforwardly, I can write down the distance to be 2 meters. The displacement is also 2 meters, but be careful that displacement usually has a sign, and therefore because we moved upwards, I write down plus 2 meters. Now when this ball is falling down from this height, it's going to again traverse some distance. So I write down distance to be again 2 meters, whereas displacement is minus 2 meters because the ball fell down. And if I try to find out what is the total distance in this motion, it's 4 meters, 2 for going up and 2 for coming down. But the total displacement is 0 meters. So you can see displacement can be positive when the ball went up, displacement can be negative when the ball went down, and displacement can also be 0 when the whole motion is considered together. And because displacement can be positive, negative or 0, Average velocity also can be positive, negative or 0. Finally, we come to the last point. We say that for a given interval, if we recall, distance is usually greater than displacement, and in the worst case scenario, distance is equal to displacement. And this happens because by definition, displacement is the shortest distance between initial position to the final position. And from this we can make a very important conclusion about average speed and average velocity. We know that average speed is proportional to distance for a given time period. Average velocity is proportional to displacement for a given time period. And by looking at the relationship between distance and displacement, I can comment on the relationship between average speed and average velocity, and I say simply that average speed also must be greater than or equal to velocity. So these were the different points of difference between average speed and average velocity. If you like the video, please subscribe.